For thousands of years, the smallpox virus was a global scourge, blinding and killing millions as it relentlessly invaded human cells. To stop the devastation, scientists introduced a targeted intervention. They vaccinated populations with a milder cousin, the cowpox virus, triggering the human immune system to produce protective antibodies. The result was a massive, coordinated public health campaign that completely eradicated the disease from the face of the earth. How exactly did we pull that off? When a scientific theory is applied on a global scale and actually works, how do we explain that undeniable success? To make sense of a physical triumph of this magnitude, we have to adopt a philosophy of science that gives us a rigorous, logical reason to trust scientific methods in the first place. There is a school of thought known as relativism, which argues that science is largely a subjective social construct. It claims there is no objective truth, only multiple, equally valid realities based on our perceptions. If we apply that logic to smallpox, it hits a wall. If a virus and the antibodies that fight it are just subjective narratives, a global vaccination program couldn't possibly cure a physical disease. Philosopher Hilary Putnam framed this problem perfectly with the no miracles argument. He pointed out that scientific theories, whether they are eradicating diseases or applying Newtonian mechanics to put a human on the moon, must contain actual truth about the world, because otherwise their consistent success would be a literal miracle. This brings us to scientific realism. It is a philosophical framework that provides a logical, non-magical explanation for why our theories work in the real world. Smallpox wasn't defeated by a miracle. The intervention succeeded specifically because entities like viruses and antibodies exist in an external reality, completely independent of human perception. Realism is built on 4 central pillars. The first is classical realism. This timeline shows that the universe is over 10 billion years old, while human representation has existed for only a microscopic fraction of that. This massive scale proves the physical world exists entirely on its own, independent of us. The second pillar is fallibilistic realism. Science doesn't deal in absolute certainty. That is the domain of theology. Instead, realism accepts that human knowledge is inherently fallible and prone to error. Because we make mistakes, we need the third pillar, critical realism. This is the requirement that science use rigorous, self-corrective methods to strip away perceptual noise and isolate true signals from the data. Finally, there is inductive realism. This means the long-term success of a theory warrants the belief that the entities it proposes actually exist out there in the world. Together, these 4 principles form a sturdy foundation. They give researchers the confidence to test theories, refine measurements, and steadily build reliable knowledge. Realism often clashes with another philosophy known as logical empiricism. That approach suffers from the theoretician's dilemma, the rigid belief that science should only trust things that can be directly observed. Strict empiricism falls apart in practice. Take genetics. Researchers James Watson and Francis Crick successfully mapped the DNA molecule, even though the double helix structure was completely invisible to the naked eye. We see this exact dynamic in the social sciences. This diagram illustrates a reflective measurement model. We can't see a concept like brand equity under a microscope. It is an unobservable, latent trait, but it undeniably exists and drives consumer behavior. By tracking observable indicators like survey answers, purchase patterns, and brand loyalty, researchers can triangulate the data, confirming that invisible core is real and measurable. Realism empowers science to look past the surface. It justifies our ability to measure and act upon the invisible forces governing biological systems and human societies alike. Scientific progress rarely happens in massive, sudden leaps. It moves forward through incremental victories, discovering a new entity here, or slightly improving a measurement technique there. This philosophy directly impacts the daily ethical reality of anyone conducting academic or commercial research. Every time a researcher publishes a finding, they enter into a trust compact. Clients, students, and the broader public are placing a fiduciary-like trust in the integrity of the methods used to reach that conclusion. Warning tone: if we embrace relativism, we erode that trust and slide toward societal nihilism, where no data can be believed. If we embrace strict empiricism, we artificially blind ourselves to the complex, unobservable mechanisms driving the world. Scientific realism demands that we defend truth and objectivity. By doing so, it honors the trust society places in science, ensuring the knowledge we produce remains reliable, actionable, and real.